Hello Year 10. Today we are looking at average and instantaneous rates of change. The average rate of change is the gradient of the line between the 2 points. So if I wanted to know the rate of change between this point and that point, I'm effectively drawing a line between those points and I want to find the gradient of that line. So we have learnt to find a gradient. We do y2 take y1 over x2 take x1. So this is going to be our formula to find the average rate of change. However, if we want to find the instantaneous rate of change, so that's not change over a whole lot of time, that is the specific change at that one point. So the instantaneous rate of change can be approximated by the average rate of change between two selected points. So I want to know the rate of change at this point P here, but I don't have enough information to find that. Instead, what I do is I find another 2 points, so A and B here, that have that same slope, and I use that to approximate the rate of change of P. Final dot point here says that average speed is equal to the average rate of change of distance over time. So let's have a look at some questions. Consider the relation with a rule y is equal to 4x cubed plus 2x squared minus 5. Find the average rate of change of y as x changes from 3 to 4. So we have a point at x equals 3 and a point at x equals 4. If I want to find the rate of change, which means I want to use that gradient formula, I need to know what those are as points. So when x is equal to 3, we use our calculator to sub 3 into our equation. So we go 4 times 3 cubed plus 2 times 3 squared minus 5. And you press equals and you would get 121. So that's our first point. Then we sub in that x is equal to 4 for our second point. So and 4, comma, and go to your calculator again and type in 4 times 4 cubed plus 2 times 4 squared minus 5, and you will get 283. So those are the 2 points that we want to use. Now we're going to find the rate of change using our formula. So average rate of change is equal to y2 take y1 over x2 take x1. So this is going to be x1 y1 and x2 y2. Subbing in, we're going to get 283 minus 121 over 4 minus 3. That equals 162. So the rate of change is 162. We don't have any units to know what that is measuring, but we have found it. Let's do the next one in the same way. So we want to find the rate of change between 0 and 4. So now we need to know when x is equal to 0 into the equation. 4 times 0 cubed plus 2 times 0 squared, that's all just 0. So it'll just be minus 5. To the point when x is equal to 4, which we already know that subbed in makes 283. So the average rate of change will be equal to y2 take y1 over x2 take x1. So this time it'll be x1 y1 x2 y2. So it will be 283 minus 5, which will become a plus 5, over 4 minus 0. That is equal to 72. So in a much shorter interval between 3 and 4, we had a much larger rate of change. but over a bigger space, it has averaged out to be a smaller rate of change of 72. On to the next page, question 2. The graph shows part of a curve with a tangent drawn at A to illustrate the instantaneous rate of change at that point. Find the gradient of the following line segments. So we want to go from A to B, which I'll zoom in a little bit here. So A to B, you can see that section there in green. So we have A is the 0.35 and B is the 0.45. So if we want to find that gradient, so we can go back to calling gradient M, we're going to do the y2 take y1 over x2 take x1. So using those points, we're going to have 5 minus 8 over 4 minus 3. That's equal to -3. That's a gradient of -3. Okay, moving on to the next part, we want to do A and C. So A and C, A is already highlighted in yellow, but I'm going to change that now. I want to use A again with the point C down here. Using the same formula, we are going to do M equals y2 take y1 over x2 take x1. We are going to sub in 2.75 minus 8 over 4.5 minus 3. That equals -3.5. So what is happening there is that we have some different lines that are coming out of that point A. The blue one is probably the tangent. The green and the red are other segments that have been drawn to try to approximate that gradient. Now both of them are steeper than the blue line that we are trying to approximate. So in part B, it says which of the line segments, AB or AC, gives a better approximation to the instantaneous rate of change at point A. Give a reason. So which one of those two is closer to that blue line that we're trying to approximate? And the answer is the green line, which was from A to B. So he's closer to that tangent. So AB, as it is closer to the tangent. Question 3. A journey by vehicle covers 700 kilometers in 9 hours, and it is shown. Find the average rate of change of the distance. Now, this rate of change is also called the speed over the 9 hours. So the average rate of change is that I'm starting at this point at the origin, so this point is effectively 0, 0, and I'm ziggy-zagging a bit there with different speeds, but we end up at this point 9 for 9 hours and 700 kilometers. So approximating the gradient of that red line using my rise over run, or my y2 take y1 over x2 take x1. So I would get 700 minus 0 over 9 minus 0. 700 over 9 equals 77.8. And this rate of change is the same as the speed. So this is measured in kilometers per hour, because we're traveling 700 kilometers in 9 hours. So 700 divided by 9 is 77.8 kilometers per hour. Okay, that is the end of our theory section. Time for you to do exercise 7I.